Welcome everyone to another breaking news evening IT talk here. Today, modern insanities, you have seen it often enough here on my channel. On one hand, Microsoft joins with other companies forming a eBPF foundation as part of the Linux Foundation. And yes, Microsoft was previously already part of the Linux Foundation. Amazing stuff, right? 2021. That's probably the topic of another video. As well as, does it really need a eBPF foundation inside the Linux Foundation? How many foundations does the Linux Foundation really need? But whatever. So Microsoft already previously seen bringing eBPF to Windows. eBPF, otherwise Berkeley packet filter. So what are we talking about? So previously BPF, although the foundation writes it's a revolutionary technology with origins in the Linux kernel. So what is it? So this is actually pretty old stuff, well, kind of sorta, 28 years ago. I would actually say that Linux was, not sure if Linux was actually the first one. BPF is available in most Unix systems. Maybe the eBPF JIT stuff was the first Linux kernel, but anyway, doesn't matter too much. So revolutionary technology, only 28, soon 20 years old. What is it? Previously, Berkeley packet filter was, as the name implies, for packet filtering. So to control, for example, firewall rules. So you had a certain kind of operations like check this byte, matching IP addresses and stuff, and run this in the kernel. And so this was like interpreted, and later, so interpreted meaning slow, being like having opcodes like load, store, compare, and so on. Why? To make this safe, otherwise it would obviously not be safe to load arbitrary code into your kernel that could crash left and right. So this was invented nearly 30 years ago to have rules initially for network, later in the Linux kernel for everything else, to retroactively modify the behavior, because you cannot just, well, recompile your kernel, but to dynamically load additional high performance stuff nowadays. Why is it so insane, you might ask? So this is only the summary of what BPF is. And nowadays they revolutionary use it for everything as a kitchen sink. Probably I mentioned this already in previous videos. The problem with that is, I said this already in multiple live streams, I don't think this can be done safely, because you're still loading relatively arbitrary code into the kernel just in sync Java. So basically this is similar to Java bytecode. Of course it's not Java, it's a subset of Berkeley packet filters. Why is it so limited? Because so that this can be verified, right? Otherwise root or some admin user could load malicious code into your kernel. So this needs to be extremely, so it's not like C or assembly where you can like program arbitrary stuff. So this is intentionally a very limited filter set, extended Berkeley packet filter, so that it can be verified in the kernel to be safe. And there have been already multiple security vulnerabilities. I said this before here on this channel. As an example, so first of all, from my 20 years of experience, that it's like, yeah, there will always be bugs in there. There, as seen, jump addresses, conditionals, and lots of other stuff. And maybe even use after free, especially even in the verifier, right? Even maybe, not maybe, I mean, then like not breaking this by the limits of eBPF, but breaking this through the limits of the verifier, actually like crashing the verifier and using that to run malicious code. Crazy stuff. I wouldn't recommend this. They portrayed here as the latest and greatest since sliced bread and revolution technology. Why do they do this? Because performance. Monolithic single address-based kernel is not enough, so more JIT, obviously, for more performance. For like virtualization and special use cases of profiling and instrumentation and other fun stuff. So why is it newsworthy? So on one hand, they in the news today, hey, Microsoft is joining this, they bring this to Windows already, this news weeks, a month ago. And on the other side, so on one hand, JIT in the kernel, right, because performance. On the other hand, in the news today, Microsoft brings super duper secure mode to Microsoft browser, Edge, Chromium. Actually, it's not today, it's 8 days ago. Anyway, relatively breaking news. So what have they found? Security versus performance. And in the context of the browser. In the browser, we have something quite similar. We have JavaScript, the latest and greatest revolutionary invention some decades ago. Obviously for running arbitrary code on your client's browser, right? Similar to in kernel, just in the UI. And for performance, you guessed it, similar to Berkeley packet filters, you want to JIT this, right? Just-in-time code generation, because similar to eBPF, where previously this was interpreted like a program would load the bytecode, okay, we load this, at like each step in the bytecode is executed, interpreted step one by one. So this, what is the problem with this? This is like a magnitude like 100 times slower. So you want to JIT this, right? JIT meaning similar to JavaScript, instead of step by step, load, add, sub, divide, and all the stuff in the JavaScript, compile this similar to a C or Rust program for performance, and then run this 100 times faster for 3D games and layout stuff and animation and even image and video processing in your browser. So it turns out similar to kernel vulnerabilities, right? What is the problem? Yeah, you guessed it. For decades we have vulnerabilities in your browser, right? And then malicious actors, state actors, or just for fun and profit, ransomware and cryptocurrency. Yes, advertisements have mined cryptocurrency in your browser. So vulnerabilities, right? And so what is the latest and greatest research of the other side of Microsoft browser vulnerability research? Security versus performance, reconsidering the trade-offs. So they move JIT into the kernel and in the browser. Maybe this is too insecure for the browser. So they bounce between offensive and defensive roles. Favorite target is always V8, JavaScript engine. Bugs are mainstay for attackers, various reasons. However, as a defender, this is a nightmare. Regular stream of bugs requires frequent security updates of your browser and your operating system, right? And the problem is not unique to V8. It's a common problem. Most modern JavaScript engines, Google, Mozilla, Microsoft, others, mitigate this risk. Mitigates this even with sandboxes, right? But you guessed it, sandboxes also at times leak vulnerabilities, right? Human mistakes by the programmer. So what they found, so turbofan pipeline, similar there, they first interpret this and then how does a modern JavaScript JIT works? Usually they first interpret this, and if a code block is run multiple times, say 50 times, then it's hot enough and worthy to be JITted. Otherwise, if it only like on startup, why do they do this? Because if code runs only once at startup, it's often not worth JITting this, because JITting code generation usually takes longer than just interpreting this. So this is why they have a balance between first to interpret. If it's like hot path detection, then trace JIT or variants of that, JITting this eventually hot code paths so that your video and image processing and YouTube video and layouting and all the other snappy stuff is snappy. So what they found, face the entire V8 processing pipeline, recently added second JIT called Sparkplug. Yeah, also one JIT is not enough. You need turbofan and Sparkplug. Added second JIT. Yeah, so 2021 one JIT is not enough. They come not alone anymore. Now they come together. Meet Sparkplug. So that I think this is whatever. I also can't remember each detail. Whether one, obviously one probably, if the code is very hot or a single instruction multiple data, eventually it's more optimized and more inlining and so on. Anyway, so performance and complexity often comes, yeah, so super complex stuff, right? Not interpreter, then JIT, and then even a second JIT, because you can never have enough, the more the merrier. And looking at the CVE common vulnerabilities and exposure data from 2019 shows roughly 45 CVEs issued, 45% of CVEs issued for V8 were related to the JIT engine. Recurring news here, right? For those probably you want to share, like, and subscribe for that. Moreover, they found the attackers weaponize and abuse these bugs as well as, like, yeah, no shit, Sherlock, if they are security vulnerabilities. Attackers obviously weaponize and abuse them. No kidding. Analysis from Mozilla shows that over half of the in-the-wild Chrome exploits abuse a JIT bug. It's like, sounds amazing for the kernel, right? eBPF, JIT in the kernel? Yeah, you guessed it. Anyway, so also Edge here refers to the legacy version of Edge. So yeah, lots of JIT bugs, obviously. So they question, so Microsoft is just eBPF in the Windows subsystem kernel and joining this eBPF, because the more JIT, the merrier. And the browser, the other side of the spectrum from the kernel to the UI, the desktop operating system interface nowadays called a browser. It's like, is it really worth it? There are so many security vulnerabilities. It's like, maybe we shouldn't even freaking JIT it. I mean, of course, this is a crazy thought, right? Also, probably, how long do we have? Probably at least 15, nearly 20 years of JavaScript JIT, at least probably 15 easily. Years of sophisticated JavaScript JIT. Mozilla went through multiple iterations. They are right now maybe on the at least second, if not probably easily third JavaScript JIT anyway. Apple with WebKit had multiple iterations, JavaScript core. Initially, I think they had some JIT. Then later they also additionally added LLVM to that. However, as far as I remember, of course, the startup cost LLVM, low-level virtual machine, used in many other projects. Obviously, relatively big set of libraries, really high startup costs. So Apple at JavaScript core also did what V8 does today to JIT, so some lightweight JIT, and if the code is very hot, think video, image, video, audio, like very hot code path that is single instruction, multiple data worthy, then eventually fully optimize it to LVM. Crazy complex stuff. So what did they found? And in my opinion, this shows multiple things. First of all, it shows multiple how insane this is, what we put into, well, not we, what some people put into their kernel. And on the other, also how after 15 years of state-of-the-art research of Apple, Google, Microsoft, Mozilla to some degree, if they're not busy implementing Pockets and VPN, then how not amazing JIT still can be. Because here they found by disabling the JIT, they can enable both mitigation. So yeah, super duper, what is the topic? Super duper secure mode to Edge, which is disable JavaScript JIT, just like yeah, you have on degraded Linux systems on PowerPC or RISC-V or MIPS, where you don't necessarily have a JIT. Anyway, both mitigate and make exploiting of security bugs in any render process component more difficult. It's like, yeah, no shit, no kidding. If you disable complex features for performance, then there are less bugs to exploit. What a state-of-the-art research. You could have that for a fraction of that price here from Exacode here at us. Anyway, the reduction of the attack surface, also, yeah, a recurring theme, what I always say, trusted code base. Recurring theme here, attack surface, don't put all the features in there, keep it stupid simple. The reduction in attack surface kills half of the bugs they see in exploits, and every remaining bug becomes more difficult to exploit. Wow, state-of-the-art research. But so what about the performance, right? In the Linux kernel, eBPF JIT, because performance, and more performance. Performance is important, obviously, for the Edge team, because the snappier the browser, the happier the user. Complicated topic, including wide range. Yeah, complicated topic because just as I outlined, starting with an interpreter, then compiling hot code paths, then theoretically Spark plugging and afterburning whatever your names might be of your JavaScript engine. Very hot code paths eventually to even more optimized inline, produce very native code, a very performant optimized native code. And obviously JavaScript plays a key role in any browser story. JIT exists for a reason, no kidding. So they looked at the result of disabling JIT in their lab, and edge performance runs hundreds of tests, mimic real world, and they found most tests see no freaking change with JIT disabled. And I have to say, what have they done? And how can, after 15 years of freaking state-of-the-art high-performance JavaScript JIT research at all the big companies, how can real-world tests not see a significant change with JIT disabled? Seriously, what the heck? The problem is, of course, with news sites and other developers, of course, often running specific tests like image processing. Then, of course, you see in this single JavaScript image processing or video processing use case, huge performance improvements. But if you browse a website here like this blog or a news site, the code might not be as performance hungry. Anyway, anecdotally, they found that users with JIT disabled rarely noticed a difference in their daily browsing. And this is, I sit here with a RISC-V unmatched, and it's slow, and they find, for what have we done in 15 years of high performance JIT research, there must, if this data point is right, there must be something gone really wrong. Well, also, of course, why is this plausible, and why is it so? Because, of course, websites are more than just JavaScript. So all the layout engine is still native code, all the cascaded style sheets, CSS, layouting and so on, and blitting and rendering of all the graphics. This is still partially GPU isolated at times, if you're lucky, plus native CPU code and so on. So probably 90. So why do they see barely a difference? Recurring theme of my copied from other, standing on others giants shoulders. The usual 90%, 10% rule that I cite here so often, 90% of the time, this is simply run native code, layouting, rendering and so on, and only 10%, at least in normal websites, right? It is different if you open a video editor, image editor like the Photoshop clone in JavaScript or whatnot, then of course you easily have at times 100 times slowdown, or think WebGL 3D games. Anyway, how much variation did they see? Page load. Also, by the way, some stuff improved, right? How much, also, I really wonder how some stuff, but it could be the overhead, right? Just starting all the JIT. So you interpret this, and then the interpreter finds some hot code path, and then it JITs this, and then it's not really often run much more often. So crazy thing is sometimes they see an improvement probably for such reasons. Also, yeah, startup improvement. This is startup improvement, 8.9%. Crazy stuff. Actually, I wanted to do some. I have actually some ideas in this area that I wanted to research for years. But anyway, and crazy enough, they even found power improvements. So they have your page load memory. So they can at times find improvements everywhere, including battery power improvements. So disabling JIT not always have negative impact. Their test measured improvements in power, showed 15% improvements on average. Regression showed around 11%. So this is of course different tests, right? One Photoshop-like editor of course shows any regression, while a news site with not that much JavaScript, where it's mostly interpreted anyway, might show actually an improvement. So memory is a mixed story, but 2.3%, who cares? Page load times show most serve decrease with test regression averaging 70%. Startup time, however, has only a positive impact and no regressions, crazy stuff. So disabling JIT does result in significant lower scores in JavaScript benchmarks because obviously they have more hot code paths. That test shows a decline as high as 58%. However, often users do not notice impact because users obviously do not run benchmark unless they play 3D GL Doom in or Quake in their or Crysis in their browser. So they wonder performance gains provided by JIT versus the resulting security bugs. Also, you could actually, I mean, the low-hanging fruit, right, could be only JIT stuff if something is really JavaScript heavy, right? So that, I mean, it's like easy idea for 2 cents here live on this channel. Like, yeah, then only JIT stuff when it's like really hot, like maybe simple as increasing, not like, as I initially said, interpreted functions and stuff, loops run 50 times, just lower this to 5,000. Maybe you have all the savings and yet do not lose as much benchmarks when you run fire up Crysis and stuff. Anyway, project super duper security mode. It's like, yeah, TM registered trademark. For like, yeah, AKA just freaking disable JavaScript JIT, turbofan and sparkplug. Crazy stuff. And isn't that not insane that also the left hand doesn't know what the right hand is doing, is a saying we use here quite a bit. So on one side, Microsoft joining eBPF, Linux Foundation, sub-foundations for in-freaking kernel JIT. On the other side, yeah, it's too difficult. It's too, well, of course, we are comparing apples and oranges. eBPF is a magnitude simpler, but actually I should have opened that eBPF CVE. There have been already multiple, not making this stuff up, Kubernetes container escape using eBPF, on a Linux kernel eBPF. We had this multiple, including probably that one. So yeah, incorrect bounds, 0-day, Linux kernel, privilege escalation, improper eBPF. I'm not making this shit up, this is real. If you are interested in all these details, you probably want to share, like, and subscribe. It's not the first time we discuss this, it's just breaking news. What insanity scrolls by during the day, and I wonder what the freaking heck are these companies even doing. Anyway, that's it for this video. Let's quickly take a look at the comments. What do we have going on there? Maybe some people tuned in, that is amazing. EEE, embrace, extend, distinguish, maybe Microsoft strategy. Yeah, just on the other side. I mean, of course, we get some free research and money for the Linux Foundation, so yeah, YOLO, whatever. I don't have to use this. But even in the Linux kernel, I would actually not really use eBPF because Neuer's 303, right, you have a point, but the circumstances are not equal. JavaScript you basically get with every ad. eBPF will not be served by your ad network. JavaScript is not verified. eBPF. Yeah, I said comparing apples and oranges. However, JavaScript should always inherently be safe, kinda, sorta, because you don't have pointers there. You have their variable like let a equals b something, DOM, window, button, and so on, and moving stuff around. So theoretically, JavaScript should also be safe. Yes, it's a magnitude more complex. Also, I mean, it's not dealing with pointers and addresses, right? So maybe it's not even a magnitude more complex. And it also should only be allowed to do what it's allowed to do in the browser, and not like the usual use after free, out of bounds and stuff, and triggering other code generation bugs in the code generator. Dr. Schubert writes, makes sense because eBPF generally doesn't run arbitrary code from the internet. Yeah, but it's still breaking out of containers, so it can still, if you are a cloud provider, microservices or other containers, people breaking out there, or users in a multi-user system, And in general, the question is, in my opinion, as most research has shown, yes, getting a microkernel fan here, I would actually see more, as I said already multiple times on this channel, I would actually like to see more address space separation, even single drivers or at least subsystems, think network subsystem, storage subsystem in separated user tasks. Yes, that comes with some performance penalty, but I'd rather take some percentage of performance penalty, and microkernels have been shown to be fast, think QNX, L4 and similar stuff. This day and age of complex IT, especially virtualization and stuff, and connected things, microservices, serverless means server more services out there, and everything being connected, every house, maybe even smart home, and well, all the industrial production and infrastructure stuff. Simply, who cares about 10% performance if your network infrastructure, your power plant, your water supply and so on, your self-driving car, car charger, all the 100 examples are insecure. More comments: user space should still not be able to run arbitrary code without managed permissions. The eBPF JIT hopefully is magnitude simpler. Yeah, it is simpler, but even simpler is not enough, right? As seen here, and this is, yeah, quite some. And I mean, each of those is too many, right? And this is also, if the question is also, means this is only for performance, or retrofitting features and tracing to the Linux kernel or Windows kernel or other kernels. Should this not simply be done differently and not, is similar here? I would actually argue the same is as they found here. I mean, I would even, this is actually, JavaScript is not a very nice language, right? I would actually prefer, because there are so many strange behaviors, implicit type conversion, and you have seen this. This is what examples of strings or objects adding to stuff with this implicit conversions, and like adding a number or a string with an object automatically converts this to whatever table object, whatever, something. So it's not a very nice language. I actually would prefer something that, but the ship sailed obviously 15 years or 20 years ago when JavaScript was invented. I think JavaScript would be much better if it would be more simple and more streamlined, similar to Lua, and without all the strange features that accumulated over the decades. That would also make it easier to JIT and work with and stuff. So, and I would actually not even agree with them, right? As the web is the new desktop, obviously, unfortunately, it needs to be as snappy and performant as possible. And it is crazy that I would actually expect like long-running websites of working here. Okay, on the other hand, most websites are just reading text, so it's not like long-running. I mean, it's nothing is really long-running when we read a blog or a website, but I would expect this to be more power efficient if it's native code. However, apparently all the overhead, startup cost and overhead of all the massive libraries similar to code generation and compiler technology like LLVM is just so much overhead that all the efficiencies are immediately consumed of that. Maybe, well, what would be the solutions, right? I mean, for kernel, I would argue I would totally not want this at all. Too much complexities. Kernel should be microkernel, as most research has shown. Probably no research paper has shown we should do complex systems with a single address space, everything and the kitchen sink clobbered together. This should be modular in namespaces, in single address spaces, like good practices of software development. And yes, performance, even if it's 10% slower, then just build better CPUs that have microkernel optimization spec'd in, which would have been amazing for a decade or two already. For the JavaScript side, I would argue, I think the web would be a better place if JavaScript would be simpler in the way that Lua is, without all the special casing stuff and type conversion stuff and other craziness. Less error prone to program, easier to JIT, and reduce complexity, reduce bugs. And additionally, maybe nowadays, theoretically, WebAssembly, certainly a performance advantage. Not sure if it's the best idea to WebAssembly who will JavaScript replacements for dynamic layout like YouTube and Google and news sites and stuff and vlogs. It's just some crazy idea. The problem is, of course, there as well, running arbitrary code, and that is not verified. Also, again, WebAssembly has nothing to do with assembler. It's similar to Java or eBPF. It's bytecode with limited features. Yeah, it will be interesting to watch this, especially as web obviously is so prevalent in today's IT news. So yeah, full with security vulnerabilities and full with performance demands. That will be interesting to see. And from my side, as I said, the simpler the better it would probably have been, but this ship has sailed. Maybe there should be some JavaScript NG or JavaScript 2.0, although yes, there is ECMAScript. Internally, that's even ECMAScript, not JavaScript. Of course, internally, that is version whatever. But just saying, like, maybe there should be some JavaScript 2.0 with all the craziness removed. Maybe that would help quite a bit. Let's see, more comments, and then we should be done, keeping this a little bit more streamlined for people to watch it later. How long do we? 30 minutes, yeah, that's probably already too long time. Neuer 303 writes, disabling CSS, you probably remove another 50% of bugs. Yeah, however, I mean, CSS, I understand, right? Also, CSS may be a little bit feature overloaded as well, but CSS is only cascaded style sheet layouting. I mean, obviously you need something to lay out that, and it's not direct code execution, also all the opaqueness and alpha blending and stuff. But yeah. So Mr. Destructor Hack writes, the main problem people keep leveraging mitigator bar instead of solving the underlying problems. Count 2021 still memory corruptions. Yeah, memory corruptions, out of bounds, use after free, all the, yeah, basically memory corruptions. On the other hand, exploitation market will the 3 years. What? On the other hand, exploitation market will be dead by 3 years from now. I don't see that. The exploit market will, my impression from the IT industry is the exploit market will be booming for years and decades to come. Just with all the legacy, with all the complexity, this will not solve in 3 years, and because nobody follows my recommendations here anyway. So Frank Dressler writes, most JavaScript developers also do not know how to write code that can be JITted well, so that is also true. And yeah, also the problem is I've seen this websites like this, but just browse something, your newspaper, your favorite food vlog or travel vlog, full with JavaScript modules, easily like 10, 20 freaking JavaScript frameworks and trackers and networks and whatnot. So obviously tons and tons and tons of code, and certainly the same applies. Keep your freaking website stupid simple. Also helps with performance, load times, and so on. And so what else do we have here? One problem is, a separate problem is that nowadays a lot of native desktop applications are Electron based, meaning web applications based on Chromium, but that's a topic for another video. I mentioned this a couple of times already, but probably I need to make a dedicated video. Did a good question, memory, tagging, other kind of protections, they skip properly. And I think on iOS still you get JavaScript disabled, right? Only Safari has JavaScript JIT enabled. Not sure if third-party browsers can enable it, but if you just use the web view in your application, usually you get JavaScript disabled just for that reason of Apple came to that conclusion already a decade ago of like, we don't give the people JIT because JIT is too dangerous. It can just generate and exploit too much code. Similar to Zilon Bono writes, similar to Intel and their shortcuts in their CPUs, they should have been written Rust in Rust. Rust is now the silver bullet also. Yeah, Mr. Destructor Hacker writes, Rust is not the silver bullet. It also has bugs. Yeah, so true. And in my opinion, lacks a little bit readability, but it is also, yeah. Last comment. Of course, not the silver bullet does not exist, but eliminates a whole class of errors. Yeah, certainly agree. Usually, I otherwise recommend Rust here in general. Just personally, I find it a little bit hard to read. I wish the Rust syntax and would be a magnitude more readable, as well as I'm not a fan of this cargo micro dependency system that Rust itself needs around 200 micro dependencies, and all the packages rebuild their micro dependencies and also automatically fetch them from the internet. Yes, I understand developer convenience, but I personally don't like if I build something like Alacrity or Terminal Emulator or any other like Firefox and then fetching random stuff from the internet. I want one tarball of sources that people can verify, and researchers who reads a million lines of code, but eventually people will do. I want one reproducible tarball and not Rust and Cargo fetching their tons of packages from the internet. But that's all previous videos, and that's it for tonight. I hope you learned something. Leave in the comments what's your take, what do you think, and don't forget to share and subscribe for all the next videos and tinkering and low-level code here to come.